Hello and welcome to the Extended Greg YouTube channel. I'm Greg and today we're going to be doing a hard drive installation of Alpine Linux on Raspberry Pi. We're going to be covering it in two ways. We're going to be doing it through the SD card as well as using a USB thumb drive. Before we get into it, be sure to smash that like button and subscribe if you haven't subscribed because we're about to get extended. So let's get right into it. So what I have here is just a regular Raspberry Pi. You know, I do have a PoE adapter on this, but I mean, at the end of the day, it works for all versions of Raspberry Pi, and it even works for desktop installations as well. But we're going to be focusing on the Raspberry Pi today. So we have this USB thumb drive. It's a 64 gig thumb drive that we're going to be using to install first. We also have this MMC, or I should say SD card, shows up as MMC, that we're going to be using as well. To be able to install it. And the idea behind this is that we want to be able to open up all of the RAM available using Alpine Linux for development, doing compilation, things like that, or even if we want to host a database and have a simple way to be able to have persistent storage. So we're going to set that up in two ways. We'll go over what the options are as we go, but pretty much that's what we're looking at. So jumping over to KVM here really quick, I'm going to insert the USB thumb drive, and I've already done a test installation of this, so we are going to see some files on here pop up. Good, it didn't. Okay, so what we're going to do first is we're going to clear the hard drive. There it is. Let me close out of this. Yeah, and I'll show you what it has currently on there. So right now it shows up with two partitions, and that's really the end state that we're going to have. But let's go ahead and clear that out, because let's say we didn't know what this data was. We want to make sure that we're starting from a clean slate to make sure it boots properly, and that everything is working as expected. So we're going to open up a command line. Don't ask me why. All right. And we're going to go over here and we're going to do disk part. And this is exactly the same. I'm going to just confirm a prompt here. This is exactly the same as the regular installation of Alpine Linux at this point. So we're just going to list the disks. And we see it shows up as disk 4. So we'll do select disk 4. And now we can just do clean. And we see it goes to unallocated immediately. Ignore the error. It doesn't actually matter. So we see that now we have a completely blank USB thumb drive, and everything is unallocated. So what we're going to do is we're going to create a new simple volume. And we're just going to use the entire space because it should boot just fine. And we're going to give it an arbitrary drive letter. Under the file system, we'll choose exFAT and we'll call it Alpine. And finish. And now we'll have a single partition that opens up on the screen to be able to show us that it's an empty folder, which is what we would expect considering we just formatted it. So now what we're going to do is we're actually going to extract the standard files that we did. I just downloaded this particular tar file, tar.gz file, directly from Alpine's website just a few minutes ago. So I've just opened it in WinRAR, and I'm going to extract all of those files over to that drive that we just created called Alpine. So that's going to happen for a second. It's just going to create a standard bootable drive, and that's, you know, one of the easy things about Raspberry Pi is that you just copy over those files instead of having to do the installation. If you do this on x86 PC or 64-bit PC, it is a little bit different. My cat wants to say hello. I say hello? Who's this? Who's this little cutie cat? That's you. She's gonna sit on my lap while we're doing this, and I know it's going to be great because she's not going to start walking on my keyboard. We'll see. So now we have all of the files extracted to that drive. We're just going to eject the drive, which I have to do from another screen, and we're just going to plug it into the Raspberry Pi. So we'll switch this over. Right, nothing special going on here. And we're just going to both keep the cat wrangled and plug it in. And we'll switch over here, just get ready, because we're going to boot it up right now. Just got to get a cable or two connected. All right, and just so you know, if you don't have USB booting on your particular Raspberry Pi, you may need to actually boot from Raspbian to do a firmware update before it will actually boot off of USB. That was not a function that was enabled by default. And let's see here really quick. Oh, it says it can't read the FAT file system. So if you get this error, and specifically this right here, what that's saying is it can't read exFAT, and it's because we used over a 32 gigabyte drive that it's not able to do it. So we do just need to do one quick modification here. So we'll switch back over to the PC, plug this back in, and we're just gonna pretty much repeat those same steps, but with a minor exception. And this time I'll even zoom in for you so you can even see what's going on. We'll try that out. Right, so I have disk port open. I'm going to do list disk, select disk 4, clean, exit. We'll keep this open just because it's easier. Right, so now we have unallocated drive. Instead of doing the full drive space, we're going to do a simple volume here. And we'll just go ahead and set it to 32768, which is 32 gigabytes. We're going to hit next and just again give it an arbitrary drive letter, but instead of exFAT showing up, it will show up as FAT32, and 32 gigabytes is the maximum file size for FAT32 under normal conditions. And we'll just do Alpine. Quick format's just fine, same deal as before. But now we see that half the hard drive, or half the drive, is not used. Right, so right here, we're only using 50% of the drive, but that's okay, because when we do the installation, it will use the entire drive. Now that we have this, we'll extract our files once more. And this should only take a second. It's only about 180 megs. It's actually very small. Now, something I will say is that if you're using some of the older Raspberry Pis, they can have difficulty with actually doing the installation just because of pretty much a loss of support. Some of the Raspberry Pis are pretty old at this point, over 10 years. So it does make it a little bit difficult for them to keep adding features, but then still support the ones that have very small amounts of RAM. Right, so I'm going to inject that drive. Go back over here. Just going to plug it in again. All right, and it is booting up. Let's keep an eye out for it. And if you ever get stuck where it has no HDMI output, it is also possible to completely unplug any USB thumb drives or anything else like that and let it go into its boot cycle. And I'll actually show you that right now. So I have no drives plugged into it at this point, right? So there's no USB plugged into it. And actually I should put it over here just so you can see something happening, right? So I have it powered on I'll actually do it again. Right? So right now there's no drive plugged into it because the drive is right here. There's no USB or no SD card, anything like that, but we see the green light is still going on. And if we switch back over to the KVM, right, we see that currently it is just booting from pretty much its ROM. So it's not booting to anything per se, but it would let you net boot, for example, or other things like that. So now that it's trying to just continually search over everything, we're just going to plug in the USB drive. We do see that it says the connection is enabled. And with any luck, we should just boot right off of it. So let's see what it does. Right, so now we get the color screen indicating that it is booting successfully. We are launching Alpine Linux, so it is successfully booted off of the drive itself that we just created. We're going to log in using root. I'm going to select the right keyboard. I'm going to plug in the keyboard and then select it, and then log in with root. And pretty much we're going to do setup Alpine the same way that we would for any other installation. So I'm going to choose my keyboard. I'm going to give it a name. In this case, we'll call it USB Alpine. I'm going to configure network. Let it discover it really quick. Give it a nice strong password. Set the time zone. No proxy in this case. Set up NTP. Set up repositories. I'm going to enable the community repository just because. I'm not going to set up a user. I am going to set up OpenSSH. Although it's not required. No SSH key. At some point we'll go into that, but not today. Now, here's the critical one, right? So down here at the bottom, it says no disks available, try boot media. So because we only have one drive loaded into here, we actually do want to use this. And it's going to overwrite everything that we currently have on that drive. So we're going to do Y for yes. It's going to prompt us to confirm which disk we want to install. And we see that SDA SanDisk, which is the one that we happen to be using, and the default is none. So we do actually have to type this, but what we actually type is this right here that shows up. So if it shows up differently for you, make sure to type that. But in this case, I'll just move it over. We'll type SDA. Right, and it says, how would you like to use it? So I'm going to zoom out here really quick. Just type question mark or do let's do help, which is what it says. Question mark for help. No, it is question mark. So what this is going to do is this is going to tell us a little bit about each one. So the options that we can select between are sys, data, crypt, and then pretty much some subvariations within there, but then LVM. We are not going to be covering LVM today, okay? Which is pretty much this to this. That's a very nice bracket. So I'll even do it in red. Right, so we're not going to do this today. And we're also not going to be doing the encryption function. Okay, but you certainly could. There's nothing wrong with them. They work very well. But again, for Raspberry Pi, I don't think the LVM setup is the best option, just because generally you're not dealing with actual hard drives, although if you were doing this on an SSD, things like that, or wanted the ability to do online capacity expansion for your partitions, you certainly could use the LVM, which is the Linux Volume Manager, to be able to do that. But we're focusing really on these two options right up here, which is sys and data. And sys is pretty much like your traditional boot. So any other Linux distributions like Raspbian or Raspberry Pi OS or Kali Linux or any of those are going to be using sys type install. And what that is it's just going to pretty much have everything on one partition, like a boot partition, plus your data, and it's all the data for the OS, and it's always mounted all the time. The other option is to do data only. And pretty much what this is going to do is it's still going to run your OS off of RAM, but it's going to keep your data on a separate partition. So this is good for like development purposes, things like that. So we'll try it both ways, but first we're going to do sys, right? So I can't see it under my thumb as I'm trying to move it, but you get the idea. So what we're going to type is sys. Right, and we see it's no kernel found. Ignore that. It doesn't matter. It's just because we're using the Raspberry Pi image. It would find a kernel if it was using the other one, but it doesn't actually matter. And then it's asking, it wants to confirm that that we want to erase this disk. We're going to do Y for yes. It deletes both of those, and it's going to create brand new file system, which in this case is a FAT file system for the boot drive, and then it's going to do the ext4 for SDA2 in this particular case, which is going to store all of our data and the OS. So now it's pretty much gotten to 100%. We're going to let it finish. Wait for it. So it does take a second, but we're overwriting our boot drive. It says installation is complete, and now we can reboot. Right, so we still have this here. There's only one drive. I haven't secretly added another drive or anything like that to the actual Raspberry Pi, and we'll just do reboot. Now, something for reference is if you've ever tried booting into Alpine Linux, and we didn't do lbu commit-d, we only did the regular install, and we didn't actually finish ever running the setup Alpine. So we never did lbu commit. So normally we wouldn't have saved anything. But if you look as it's booting up, it is actually configuring our Ethernet right here. Wow, it moved. And it saved our name that we set for it right here. So we see already something is a little bit different. So let's go ahead and log in. So we'll use root as our username. It does prompt us for a password now, which is what we set before. So we see it saved all of the changes that we just did in setup Alpine as after the reboot. So that's already a pretty good sign. And if we do df-h, we see we have 55.8 gigs as the size. So that's pretty close to 64. Right? And only 149 of that is used, which is pretty much the size of the image. So really, we're not using much at all. But let's test it. Let's see that it's actually saving files past reboots. So if we ls the local directory, which this happens to be the root folder for the home directory for the root user, we see nothing's in it. So let's create a file. So we'll do touch, and we'll do test.txt. And we do ls, and we see test.txt exists. So now let's do reboot. So it's rebooting. And normally, since we didn't do lbu commit, it wouldn't save anything if it was just running from RAM. So it's booting back up. We can log in again with root, give it our ultra secure password, and when we do ls, we see test.txt exists. Perfect. So pretty much that's what we would expect, and we can continue to use Alpine Linux exactly as we otherwise would, but we don't have to worry about any of the changes that we make getting lost between reboots or having to remember to save them. That being said, I wouldn't recommend this for a production setting if you're building an embedded device or anything like that, because it would be a situation where, you know, it could potentially get corrupted or things like that if you're doing unsafe reboots, or if something happens where, you know, a vulnerability comes up that causes it to write to it. So be careful how you apply this, but it's good for workstation use. So now we're going to cover a second variation of this, okay? So we'll power this off. Right, it will go down. I'm going to unplug the USB drive, and let's do the same thing with our SD card. All right, so I have a 128 gigabyte SD card right here. I have no idea if this is genuine. It just happens to be SanDisk. You know, you can use any type for this. So I'm going to put it in the reader. We'll switch over here so we can take a look at it. And right now it looks like it's got nothing on it. It may not. So we'll have to find out. Go back up here again. I'm going to do disk part. Oh, it does look like it loaded. So it is empty. That's totally fine. Yeah. So it's showing up as disk 2 over here. So it shows up as empty. So let's do disk part again. And I will go through the same process pretty much. So we'll do list disk, select disk 2, and in this case it was already cleaned, but we're going to clean it again. Right, doesn't really matter. So it is clean, it's unallocated here. We're going to do a new simple volume, and we're going to follow the same rules that we did before where we created the 32 gigabyte drive. So instead of doing the full size of the disk, we're going to do 32,768. We're going to mount it at an arbitrary drive letter, put it as FAT32. And this does work on Mac as well. You can format as FAT32. It's not a big deal. Just make sure it's below 32 gigs. We'll name this Alpine as well. Finish. We see it's only using 32 gigs. And then it brings up our folder for us. Then I'm going to open up WinRAR. And we will extract it. Extract the entire directory to our drive. We'll let that complete. And then we'll boot off of it just like we did before. But this time, instead of doing sys mode, we're going to do data mode. And data mode will still run the OS off of the actual, off of RAM, which means we'll have a little bit, about half as much RAM as we normally would during, but I would say it's the same amount that we would normally have otherwise if we were just running it normally without doing the disk install like this. So now that that's complete, let's eject our drive. I have all kinds of things in the way. There we are. Okay. All right, now I'm going to take the drive, insert it into the Raspberry Pi normally. And then in this case, I'm going to reboot it. I'm going to unplug the USB just because the KVM that I have causes issues with it trying to boot. But, you know, that's totally normal. Normal fun, as it were. So let's go ahead and boot it. Again, technically you could do the same thing where you leave it out until you actually have it booted up and then put the SD card in, and it will read just the same if you're having trouble booting. But let's see how it gets, how far it gets. Wait for it. Wait for it. Is it blinking? I don't see blinking. So let's do that. Right? So now it has no drives connected to it. We're going to plug in the power, which in this case is the Ethernet port. Let it boot up until it does the thing where it decides not, or it says can't find a boot drive, and then we'll put in the SD card. So that way we get a display and at least can have confirmation that everything is working the way we want it to. So now I put in the SD card. We got to let it cycle through once. All right, and now it's booting. And now it's going through and it's starting up just like it did before. So again, we're going to go through the same standard setup like we did before and just pretty much run setup Alpine. So we'll log in as root. I'm going to choose the right keyboard after plugging it in. All right, and we're going to do setup Alpine. US keyboard, US type. Do host name. I'm going to say this is SD Alpine. Ethernet, DHCP, no wireless. Give it a second to get the IP address. Give it an extremely secure password. Set the time zone. Set up NTP. Set up our repositories. I'm not going to set up a user. Set up SSH. All right, now we're back to disk install. So again, we see here in particular, it shows us instead of SDA1, which is how the USB thumb drive showed up, it shows us MMC BLK0P1, which is the default way that the SD card shows up on the Raspberry Pi. So again, it doesn't detect it as a disk. If we did have an SD or an SSD or something like that connected, especially on the Pi 5 through PCIe, it would show up as a disk is available here. But in this particular case, it doesn't recognize these as disks since they are removable. But it still allows us to be able to go and use it anyway. So we'll do Y for yes. Right, so it says MMC BLK0 is what we would need to type in. So we will go ahead and type that. And now it's asking us what type. So again, we're going to do data this time. Do we want to erase it? The answer is yes. Now, notice it's using make E2FS, which is how it can create ext file systems. So that's pretty much the package that it uses for that to do ext3, ext4, instead of doing makefs vfat, for example, which is what it used before to create that boot partition. It takes an extra second for it to actually go through and do that partitioning, but now we see it kind of continues and picks up where it would during a normal installation. So where does it want to store the configs? We could say MMC BLK0P1. And this will enable LBU. So that way we can still pretty much, as we install packages, things like that, we'll still need to do it, just our data will persist. And now, did I type that correctly? I did. Okay, good. It says could not find device, but I'm not sure. We're just going to use the default for the APK cache. Now we'll do df-h, and we see it's currently still showing up as half our RAM, and we don't see the other device. Well, we do. I'm sorry. Yes, we do. So right here under var is where we see the other device. Okay, that's where all of our data is going to be. So if we have a web server, if we have a database server, we could have all of the data stored there. It won't save our /root folder, things like that. We'll still have to use LBU for that. So let's try it really quick. So we'll do LBU commit-d, can't find it. Let's see. Oh, let me get rid of that arrow. Okay. So it can't do that, but let's do set up LBU, and let's store the configs. It wants an actual partition information, and I don't know that it can do it twice. So let's do none for now. Let's see what it does. And should disable it. Okay. Let's just try it. Let's reboot. It may not recognize the configuration, but we'll see what it does. We've actually done other videos before where we've gone through and created By the way, this is the default BIOS screen. It's not from the SD card or from Alpine Linux. So it may not have liked our particular install because it does look like it partitioned the entire drive as just one drive, but then overwrote our particular files for booting. So let's do this. We can troubleshoot this. So I'm going to unplug this. We'll take out the drive. Right, and we will put the drive in the computer. Let's see what we actually have on this partition. Assuming I can actually get it to go in. There we go. Right, so it says it can't recognize it. There we go. I'm not going to format it right now, but I do want to see it. So we do see it use the entire drive partition as being where it installed it. So it tried to add it as a second one for just the var file. And this is part of the reason why I don't like that mode, but it is a viable mode, especially for web servers, especially for database servers, things like that, where you actually need to have all of those files from the var folder preserved, but nothing else. Specifically like configs, things like that. So in that particular case, you would actually have, you know, your SD card running your OS, but then you would have a separate drive for the USB, like a USB thumb drive, to actually preserve everything else. So let's do this. I'm going to set this up as a boot drive really quick. So I'm not going to go through the process of cleaning it, although I could. If it gives me a problem, I will do that. Okay, it didn't. Why does this music have words? We're going to set it to 32,768 again. FAT32, Alpine, perfect, there it is right there. Did I close the other thing? Of course I did. Go back to downloads. Let's reopen this. We will extract it to Alpine again. Now, we're just going to keep the USB thumb drive as it is and just pretty much overwrite it using the process. But I think that'll be a more indicative experience of what you would see, where everything else is stored on as you would normally, with the exception of that var folder. And to be honest, I don't know why it's made... I don't know why it's in the setup... script, everything else like that, just because it is something that is pretty straightforward to be able to do yourself through the fstab folder, fstab file. But at the end of the day, I'm happy they have it. So, all right, so I just ejected it. All right, so we're gonna go back over here. Insert our drive. I'm going to disconnect the USB again. Actually, we'll do the same thing that we did before. Just so that way we could see that it is booting, so it has no drive connected to it right now. We'll wait for it to boot up without it, and then go ahead and insert it normally. There we go. Right, so it's doing its own thing. So I just put in the SD card. We're going to boot normally. Okay, just found it. Now it's booting. Perfect. So now we're in there, so I'm going to plug in the USB thumb drive, and I'm going to plug in my KVM. Awesome. All right, so we're going to go through the configuration just like we did before. So I'll log in. I'm going to log in with root. We'll do setup Alpine. Give it a host name. We'll call it SD Alpine. Right, ETH0, DHCP. Done. No manual network configuration. Let it get an IP address. Very secure password. Set our time zone. We will do Crony as the default for NTP. No user OpenSSH. I will allow root login just because that's the only user we have. Normally you'd want to set up that SSH key. All right, so now it says it has an available disk because it has a disk that we didn't boot off of as an available option. So normally here, we would just select the default, which is none. But in this particular case, we want to install to SDA. So let's go ahead and do that. Zoom out a little bit. Right, so we're going to install to SDA. How would you like to use it? In this case, we're going to use it for data, just like we did before, but this time we're going to make it so it's bootable. Okay, do you want to continue? The answer is yes. So it's going to put that ext file system on there to mount as var. Where do we want to store configs? Now we see it actually shows up correctly with a default option, which is our SD card. So we're going to choose that as a default. So mmcblk0p1, and then same thing for our APK cache. And we'll do APK update, and we'll do LBU commit, and we won't get an error. Perfect. So now we can reboot. So now it's using both drives simultaneously. Give it a second here to boot back up. While that's happening, I want to check something. Did I disable chat on this for some reason? I don't think so. Oh well. We'll figure that out later. All right, so it's logged in again. We see it preserved everything. It booted successfully. So that's half the battle. We're going to log into this again. Perfect. Right, so it preserved our settings. If we do df-h, right, we can see SDA1 is right down here. Right, that's our drive. That's got the 64 gigs available. We have mmcblk0p1, and that's our actual SD card that we're storing our configs and using to actually load. But the big thing here is that the tempfs here for slash, that's the root drive that we're booting off of for the OS, and that's half the RAM, right? And we can tell it's half the RAM because this happens to be an 8 gig Raspberry Pi, which we can tell because I wrote it on the top, but it is 8 gig. And, you know, that's pretty much going to be available to the OS, and that's going to show up as, for all the other folders, as the maximum drive size. But inside of the var folder, we're going to have that full 56 gigabytes worth of space available. So, and we could do a test here. So let's do, I'll ls the local folder again, which I'm in /root, right? So ls / or do pwd for present working directory. We see we're in /root, but there's nothing there. So again, we'll do touch test.txt. Okay, and now let's go into the var folder and do the same thing. So we'll do ls/var. And we see only these right here. And we see there's a couple of things that are mapped, it looks like. But we don't actually care about that. So we're going to do touch var/test testvar.txt. And we see the file created right there. Oh. Right, and we see the file created right there. You didn't miss anything else, but I just want to make sure that you see it. So the file is there now. So let's go ahead and reboot. I'm not going to do LBU commit or anything like that. If we were going to install anything, we would still have to do LBU commit. Actually, yeah, let's do it. Why not? Right, and we can do LBU list. And it scrolls off the screen. It's better in SSH. But point being, let's reboot. But you noticed in that list there was nothing that said var. And when it boots back up, I'll show that to you as well. Just to prove it in case you don't believe. So it is booting back up right now. All right, and let's log in. All right, we'll do df-h. We see everything's mounted as expected. We can do ls. We see the local file is gone because that's in the root folder, which is not mounted to the external hard drive. When we do ls/var, we see our test var.txt file still exists. So without doing anything special, and I'll show you again with lbu list, and we'll grep var, we see there's nothing from the var folder in lbu. Because again, it's not added by default, it's just this drive mapping that's causing that to persist. So anything you put in that folder is going to pretty much remain, and it's going to be permanently modified as soon as you make any changes to it. But anything anywhere else in your OS is not going to be something that is going to be modified, which hardens it against potential viruses or anything else that's going to modify your system, or even your own updates. So something unexpectedly borks your system, you could just reboot before saving the config, and everything will be back to normal. So that's pretty much what it is here. So thanks for watching the stream today. If you like it, be sure to smash that like button and leave a comment down below. And if you know anybody who'd like this kind of content, I would appreciate it, and I hope they would appreciate it too. Be sure to share it with them, And if you haven't subscribed, please subscribe. It helps me out a lot with the YouTube algorithm, and then hit that notification bell. That way you know the next time we're getting extended. So until then, take care.